Section 9.7 deals with probability, and I have 3 problems that I'll look at with you to try to help you out in your homework. First one says, find the probability of the following if you toss a 6-sided die twice. The sum is either a 2, a 4, or a 12. And then letter B says the sum is either odd or it's less than 6. Second problem is, in a high school graduating class of 202 students, 95 are on the honor roll. Of these, 71 are going to college, and of the other students, 53 are going to college. It says a student is selected at random from the class. What are the probabilities that the person chosen is either going to college, not going to college, or on the honor roll but not going to college? And then the third and last one to take a look at, another little story problem, says a shipment of 12 microwave ovens contains 3 defective units. A vending company has ordered 4 of these units, and because each is identically packaged, the selection will be random. What are the probabilities that either all 4 are good, exactly 2 units are good, or at least 2 units are good? Alright, so taking a look at the first one, it says find the probability of the following if you toss the 2 6-sided dice. If you toss one die but you do it twice. So I know that I have 6 outcomes when I toss the first die, 6 outcomes when I toss the second die. I know I'm going to have a total of 36 outcomes. Now if I want to, I could sit and list them all out, but that's not really necessary. Not a bad idea, not too many, but not necessary. So basically I'm going to find the sum. It says either the sum is a 2, a 4, or a 12. So remember what we're going to do here is we're going to find the probability that I get a 2, or would mean to add the probability that I get a sum of 4, or the probability that I get a sum of 12. And then the thing you have to ask yourself whenever you're doing an or is it possible that I could have a sum of 2 and 4, or 2 and 12, or 4 and 12 at the same time? That's not possible. So this minus the probability that they all happen I don't have to worry about that. Alright, so thinking about it, how can I get a sum of 2? Well, I have to roll a 1 and a 1. So there's only one way for that to happen. If I take a look at the probability of a 4, I could roll a 1 and a 3. I could roll a 3 and then a 1, and that's different because the first one was a 1, second one was a 3, where the first one here is a 3, the second one's a 1. Or of course I could roll a 2 and a 2. But I can't switch that because they're the same thing. First one's a 2, second one's a 2. Well, this is still a first one's a 2, second one's a 2, so there's only 3 ways for that to happen. Rolling a 12, of course, the only way that that's going to happen is if I roll 2 6s. And so now if I add these together, I can see I have a total of 5 out of 36. So the probability that I roll a sum of either a 2, a 4, or a 12 is 5 out of 36. Alright, so same idea. Now I want to find the probability that the sum is either odd or less than a 6. So I can do this a couple different ways. I can find the probability that it's odd, add to that the probability that it is a sum less than 6. But of course I have to look at this and say, is it possible that those two things happen at the same time? Can I have a sum less than 6 that's odd? Sure I can. So I would have to subtract out the probability of a sum less than 6. Let's do this. Less than 6 and odd. And so I'm going to show you how I'm going to do that. The probability that I would have an odd sum, well, I know half of them are going to even, half of them are going to be odd, so I know that there's 18 for this without even worrying about listing them all out. If I need to find the number of ways that I can have a sum less than 6, well, that means I could have a sum of 1 we know is not possible, 2, 3, 4, 5, and it says less than 6, so I don't include 6. Now I want the sum to be odd or less than 6. I don't want to be counting the number of ways that I can do 3 and 5 because those are already in this 18. So I'm going to just find the number of ways that I can have a sum of 2 and then find the number of ways that I can have a sum of 4. And lucky for us, we've already done that over here, but if we hadn't, we would of course list them out. The number of ways I can get 2 is only 1. I have to roll a 1 and a 1. The number of ways to get 4, I'd have to roll either a 1 and then a 3 and then a 1, or a 2 and then a 2. So there are 3 of those. And so if I add all those together, I would get 18 plus 4, or I would have 22 out of 36. And if I divide both by 2, the probability would be 11 out of 18. So there's a couple ways that you can do this. I could have found all of these and then subtracted out the 2 that I have crossed out, or I kind of combine those together and cross those out right away. Or another thing I can do is find everything that's not in here. I could find all of the even ones and the ones that are 6 or larger and subtract out. To me, this is probably the most straightforward way of doing it. If you had the entire list of 36, then you could just sit there and count them. Alright, on to the second one. It says, in a high school graduating class of 202 students, 95 are on the honor roll. Of these, 71 are going to college, and of the other students, 53 are going to college. And then they want us to find the other probabilities. When I read that, I notice a couple things. I notice that there's 2 specific things they're talking about. It's kids that are either on the honor roll or not on the honor roll, and kids that are going to college or not going to college. What that kind of tells me is that I can use one of our little Punnett squares. Or, of course, I can use a Venn diagram. The Punnett squares are kind of nice. And like I said, the 2 things I was looking at is either they are on the honor roll or they are not on the honor roll. They are either going to college or they are not going to college. And it says we have a total of 202 students. So I'm just going to continue to fill out my Punnett square, and then once I have that thing filled out, I'll use that to help me answer these questions. So, going back and rereading this, the 202, I've got that number here, so I don't need that number anymore. It says 95 are on the honor roll. This row is representing the number of kids on the honor roll, so that 95 should be over here. Of those kids in the honor roll, so in other words, of that row, 71 are going to college. Honor roll and college, this is the 71. That kind of implies that 24 are not, or I could easily subtract that to figure out that 24 are not going to college. It says, of the other students, so the ones that are not on the honor roll, 53 are going to college. So not on the honor roll, going to college, this is 53. And then it says, go ahead and figure out all the rest of it. So they didn't give me this 24, but given that information right there, I can figure out the rest of the Punnett square. I figured out the 24. If I add these together, I know that's going to give me 124. That's going to give me the total number of kids going to college. I've got the total number of kids going to college. Total number of kids, if I subtract those 2, I should be able to find out the number of kids that are not going to college. And so I'll take 202 and subtract out 124, and that's going to tell me that 78 are not going to college total. If I know the kids that are not going to college is a total of 78, and 24 of those are on the honor roll, then I can easily subtract and figure out that 54 are not on the honor roll, and then the total number of kids that are not on the honor roll would be, looks like 107. And if you want to double check, adding these together should give you 202, adding those together should give you 202. If for some reason they don't add up, then you know you've got one of your numbers off somewhere. And now I'm just going to look at my Punnett square to answer these questions. So if I choose one person at random, what's the probability that this person's going to college? This row represents the kids going to college, so it's this number divided by the total. So it's 124 kids that are going to college out of the 202. And if I simplify that down, divide both by 2, I should have 62 over 101. And there's my probability. Number of kids not going to college, well, that's going to be this one. It's the 78 kids not going to college out of 202 total. Again, divide both of those by 2 and I would get 39 out of 101. And definitely not the only way to do that. If 62 kids are going to college out of 101, well, take 101, subtract 62, that would give you the 39 for this particular problem. Alright, the number of kids that are on the honor roll, total of those are 95, but they are not going to college. Honor roll, not going to college, that would be 24 out of the total of 202. And again, divide both by 2, I can see they're both even, that's 12 out of 101. And there's my probability. So Punnett squares, like we did last year, is a nice thing, and all you have to do is recognize they're giving you kind of 2 sets of information. Honor roll, not honor roll, college, no college. Alright, on to the last one. This one, like I say, for a lot of the problems that we do, try to think of the marble problem. It says a shipment of 12 microwave ovens contains 3 defective units. Well, 3 defective units, you could almost say that's like 3 red. That means 9 of them are good. You could say that those are 9 blue, if you want to think of it that way, and there are 12 total marbles. It says a vending machine company has is ordering 4 units, and because they're identically packaged, the selection will be random, basically just saying that you have equal chance to get any one of those. What's the probability that all 4 units are good? Now, these are the good ones. So when you're thinking of your combinations, it doesn't matter which unit I get first, I just need to have 4 of them. If you want to think in overall totals, there are 12 microwaves total, and you are picking 4 of them. So in the denominator, overall totals, 12 total, you want 4 total. In the numerator, you get specific. You want 4 good ones, in other words, blue ones. There are 9 good ones, or blue ones. You want 4 of those. There are 3 red ones, or defective ones. You don't want any of those. And you don't necessarily need to write that because we know that that's equal to 1. But this is what you would calculate. And then you just have to take out your calculator and type in 9C4. So 9, remember your combination button, go to math, over to PRB here. Down to number 3, 9C4, hit enter, is 126, so there's the numerator. Divided by 12C4, and that's 495. And for most of these, when we're doing probabilities, including the ones that we were doing before, you can leave it as a fraction if you wish. Go ahead and simplify it, so I would just take 126 divided by 495. Do your math fraction to see if it will simplify it, and it will. Otherwise, just leave the decimal. That's also fine. So I can say it's 14 out of 55. Like I said, typically when I'm giving an answer on this, if you're doing the test, the decimal is probably actually better. Either one's fine. Alright, so now keep that in mind how I did this, because I'm going to do basically the same thing over here. Exactly 2 units are good. Well, I'm still selecting from 12 units, and I am picking 4. This time I know there are 9 good ones, but only 2 of them are good. There are 3 that are not good, and I need 2 of those. So again, there are 9 blue marbles, I want 2. That's only accounting for 2. I'm supposed to have 4, so there are 3 red marbles, I would need 2 of those. And now I'll go back and I'll do all my calculations again. So 9C2 looks like, 9C2 looks like it's 36. Times 3C2, which I know is 3, over 12C4, which we said before was 495. So I've got 36 times 3, divide by 495. I can instead give that decimal, or if I want to simplify it, fraction, hit math, and then enter twice. It looks like it's going to be 12 out of 55. Or you've got about a 22% chance of that happening. And then the last one, of course, has got one of the key words that's easy to make a mistake with, and that's at least 2 units are good. You're picking 4 units total, so here are the possibilities. You either don't get any, you get 1, that's bad, you get 2, 3, or 4. So either none of them are good, 1 of them's good, 2 of them are good, 3 of them are good, or 4 of them are good. They're saying at least 2. That means 2 or more. That means they want you to find all 3 of those probabilities. Well, you can see it's probably quicker to find those 2. Now, it doesn't mean you can't do this. You've already done this one right here. All you'd have to do is figure out those 2 and then add them together, because either you have 2 good, or 3 good, or 4 good. You can't have them all happen at the same time. Or, much quicker to do this. I'm going to do this to start with. Now, if you're ever doing this on the homework or the test, and you've already found that answer, there's no need to show the work for it. You can just do the probability of 2, and you can just go ahead and give me the answer. And I will know that you got it from there, or you can just say see work. Alright, so the probability of 3. Again, pay attention to this. The setup is the same. The denominator, still 12C4. You still have 12 that you're picking from, and you're still going to have 4 total. There are 9 good ones. This time I want 3 of them. There are 3 bad ones. I want 1 of them. And now I have to calculate these combinations. So 9C3 looks like it's 84. I know 3C1 is 3, and the denominator, of course, is not going to change. So 84 times 3 divided by 495 can give that decimal, approximately 51%. Or go ahead and change it to math and fraction. This would be 28 out of 55. Remember, I'm going to eventually be adding all these together. So there's the probability of exactly 2, probability of exactly 3. Now we'll find the probability of exactly 4. Alright, denominator, still 12 total. Still 4 that I want. There are 9 good ones. This time I want all 4 of them to be good. There are 3 bad ones. I don't want any of them to be bad. I don't necessarily need to do that. Or remember, we actually found that right here. So you could again just say C, work, if you want to. So this is 14 out of 55. And now if you add all these together, they already have a common denominator. So 12 plus 28 plus 14 is going to give you 54 out of 55. So the probability that at least 2 units are good is 54 out of 55, which is about 98%. Alright, now the other way to do it, which like I said might be a little bit quicker, is let's find these two and then just subtract from 100%. Alright, so let's think about it. Probability that none of them are good. There are 12 total. I'm picking 4. 9 of them are good. I don't want any of them. 3 of them are bad. I want 4 of them. That's not possible. If there's only 3 bad ones and I have to have 4, that means one of them is going to have to be good. So that's actually not even possible. So now let's take a look at the probability of 1. There are 12 total. I want 4 of them. 9 good ones. I want 1 of those. 3 bad ones. I would want 3 of them to be bad. 9C1 I know is 9. C31 I know is 3. And 12C4 is the same denominator that we've always been having. So if I take 27 and divide it by 495, if this was 98%, I should guess that this would be right around 2%. And I add the 0.5, change that to a fraction, and, oh, I'm sorry. I was going to say, something's not looking right because that should be 2%. Hopefully you caught the mistake. If you didn't, I'll come back and fix it. 9C1 is definitely 9. 3C3, that's actually 1. So it should be 9 divided by 425. Let's hope that this is 2%. And there is, oops, 9 divided by 495. Bad day. There we got it. Eventually I was going to get it. Alright, there we got it. So it was 9 divided by 425. And if I change that to a fraction, I should expect it to be 1 out of 55 if I subtracted from 1. So I changed this to a fraction. This is 1 out of 55. So there's a 1 in 55 chance that I'm going to get some, that I'm either going to have no good ones or 1 good one. That's what I don't want. I actually want the opposite of that. So I subtract that from 1, and of course I get the same answer. So this would be a little quicker. It doesn't take me that long, especially since I've already done those two. But there you go. There is your homework help for 9.7. If you're having any problems or need help, like always, feel free to come in and get help.